Welcome back to the JavaEE course. This is chapter 16, where we're going to be looking at web services and SOAP. Coming up, we'll start by explaining what a web service is, and then the two big jargon terms in web services, and that is SOAP and something called a Worstell. Now that will give us a handle on the general concept behind web services, but then we need to look at how web services work in Java. In Java, the library is called JAX-WS, and by the end of this chapter, we will have written our first web service. So let's start with the basics of web services. The point that we have now reached is that we have coded our server-side service. We have an employee management service that offers functionality to clients. In the previous chapters, we've built a web front end to the service so that users can access this service from a browser. Now that was fine, but don't forget that much earlier in the course we wrote a standalone client application. I've called it a standalone application because it was running on a different computer to the server. Well, that's not quite true for us when we're testing, because we're using the same computer for the client and the server. But that doesn't matter because the client and server are running on different Java virtual machines. And therefore, Glassfish has been using network calls to make the call across the wire here. And we've been relying on some magic for this to happen because we didn't write any networking code at all. So the call here was a so-called remote method invocation. And this has been a key feature of EJBs since their original inception. Remote method invocation is where a Java object on one machine is able to call a Java object on another machine. And by another machine, I really mean separate physical machines. The computers could be located thousands of miles apart, as long as they're on a network, of course. It's called RMI in Java, and to be honest, it's not that special because it's built into the standard edition of Java, and I think it's been there since version 1.1 of Java or something like that. Now you may have coded some RMI yourself and it's not too hard. But there is a restriction with RMI. The client object and the server object must be both written in Java. So this is where EJBs come in. EJBs feature an enhanced form of RMI where the clients can be non-Java. The name for this, by the way, is the hilariously named RMI-IIOP. Now, I can't even bear to tell you what that stands for because it's simply not illuminating. But of course, put that into Google, get onto the Wikipedia page, and you'll find out what it stands for. It's a horrible old name, and it's based on an old standard called CORBA. So with our EJB, our employee management service, this means that our clients can be written in languages other than Java, such as Visual Basic, C++, Ada, or whatever. Well, that's great, but it turns out that the underlying mechanism, which is based on this old technology called CORBA, was so complicated and difficult that it didn't really catch on. We thought it was going to be the biggest thing in the early 1990s, but it kind of fizzled out. And if we did want to write, say, a Visual Basic client calling our EJBs, we'd have to have a really good understanding of CORBA, and that would be pretty hard work. So this feature is okay in EJBs, but something better came along in the late 1990s. In fact, it was popularized in the early 2000s from outside of the Java community that solves the same problem in a different way. It was added to JavaEE at some point in the early 2000s, and you can probably guess that this technique is called a web service. A web service then is a technique for exposing our server-side code to remote clients. And perhaps the main feature of a web service is that the server and the client can be written in any language. We could have implemented the server in Java with the client written in Visual Basic, and the client code wouldn't even be aware what the server code was written in. Let's have a look at a very simplified view of a web service. If you've worked with web services before, you might want to skip this bit because I'm simplifying enormously here. But no worries, because for me, this cuts to the essentials of what is happening. We have here a client. Remember, that client code could be Visual Basic, Java, Delphi, Python, or whatever language you can think of. And over here, we have the server, located thousands of miles away from the client. Again, the server code is written in Java, .NET, Fortran. I don't care. But let's say, for the sake of argument, that the service happens to be written in Java, and it's our old friend, the Employee Management Service. But it didn't have to be. It could have been any code from any language. Our client wants to invoke the business process called getEmployee by ID. Given the client and server are in different languages and possibly running on different operating systems, how can the client possibly invoke this process? Well, the answer is in two parts. First of all, the client is going to send a request to the server using HTTP. Now, this is the standard web protocol, and since it's a worldwide standard and most languages can use HTTP, we know that whether we're VB, Java, Python, or whatever, we'll be able to send data across that HTTP connection. Now, a quick digression. If you have worked with web services before, you'll know that it doesn't have to be HTTP. It just has to be any well-recognized transport mechanism. But I want to go for the simplest possible concepts, and I would say much of the time, or most of the time, the protocol that we're going to use to communicate from client to server will often be HTTP. And now for the second part. We need to send a request to the server, and we need to send parameters with that request. And the request is going to be in the form of what I'll call from now on a message, because we're not really invoking a method on the server. The language on the server might not have methods, so we have the more neutral concept of a message, and the structure of that message isn't going to be some kind of complicated binary format. By the way, Java's RMI does indeed use a rather complicated custom binary format. In web services, we usually use a simple XML document. Now, the example I've given here is a very heavily simplified example, but I think it gets the idea across. You can see in this XML message, I've got the name of the operation I want to invoke, together with the data that I'm sending. And the key is, this format is completely neutral and nothing like making a method call. So whether the server is Java, VB, or whatever, it doesn't matter. And the client doesn't care as long as they can send this XML document to a URL via HTTP. So now the server can unpack this message and can do its processing. After a while, the server will respond with the resulting data back to the client. And again, this will be in an XML format. An example might look like this, so we can see the data that the client requested. So all the client has to do, whatever language it's written in, is it has to package together an XML message, send it across HTTP, and then when a response is received, it can unpack the results and do whatever it wants with it. Now, a quick note, the term web service for me is really misleading because this hasn't really got anything to do with the web whatsoever. There's no browser involved here. The client is just arbitrary code. This whole thing is a technique to allow standalone clients to access your services. The web part of web service just comes from the fact that we're using HTTP to connect the client to the server, just like a browser does, but that's all the name means. Well, you might be thinking, why do we need to do this? Why would we want to write the server code in one language and the client code in another? Surely it's just easier to stick with Java. But that would be missing the point of a web service. The main usage of a web service is for interoperability. We might want to build our server code in the language of our choice, and then to allow third parties, maybe partner companies or our customers, to be able to access our services in the easiest possible way. Our third parties will have their own preferred language, and it would be terrible if we had to say to them, you must use Java. So web services allow us to decouple our clients and servers, giving freedom to both sides. A good example of a project that might want to use a web service might be, say, an insurance company that might want to allow their partner companies to resell their policies, or an online bookstore that wants anybody to be able to query their catalogue using custom code to write fancy software to boost their sales. And that's exactly what companies like Amazon offer. Now, we need to get two jargon terms defined before we do any Java web services, and the first of these is SOAP. A nice name, maybe. This name is really just the term for the technique, or if you like, the protocol that we just defined. The idea of sending standard XML structured messages using HTTP. This term, by the way, was originally coined by a team at Microsoft who designed the first web services. It originally stood for Simple Object Access Protocol, but today, officially, it doesn't stand for anything. It's just a silly name, a bit like Windows XP was. Now, I guess they had to drop the acronym because I don't think it's technically a protocol, and it's certainly got nothing to do with objects. So that's the O and the P invalidated. And it certainly isn't simple, as you'll find if you go much further with SOAP. In particular, notice that the messages that I just illustrated with some simple XML are actually much more complicated. They're called SOAP messages and must follow a standard structure which is horrible. And we're going to have a look at a real SOAP message later. But perhaps an even more important jargon term in web services is WSDL. It stands for Web Services Definition Language. Now, I'll explain what it means in a moment, but I think it's more important before then to pronounce it properly. If you were to say WSDL on a project, people will think you're a real newbie in web services. So make sure you pronounce it as Worstell. And I don't know why, I still get a kick out of saying that, and I'm going to be saying it a lot in this chapter. So what is a Worstell? Well, the problem is that we need a way of telling our clients what operations are available in our service. Remember, the client will not be able to see any of the Java. So without some kind of a system in place, the client wouldn't know that they can call getAllEmployees, register employee, and so on. And it's the same for the parameters. The clients wouldn't know that when calling getEmployee by ID, they need to pass a string representing the ID in the XML message. I suppose we could write a user guide in a document form and email it to our client coders, and then they could work it out from that. But in web services, we have a more formal and automated process. The Worstell is a definition of the services that are available on the web service, together with a specification of the input messages and the return messages. It is, in other words, a contract definition, telling the client how to invoke the services. Again, since we want to be completely language neutral, the Worstell is defined in XML. I've thrown up here a very heavily simplified example of what a Worstell might look like. If you've come across Worstells before, you'll know that really Worstells are much more complicated than what you can see here. But don't worry, before long we will have a real Worstell, so you'll be able to see what they're like in full. I've tried here just to explain the general concept of what's inside a Worstell. SOAP web services work around the concept of messages. And these are the XML documents that are sent to the web service and are returned by the web service. So picking through the XML in here, we can see that there appears to be a message called getEmployee by ID request defined. It appears to have some kind of ID defined inside it of type integer. By the way, bear in mind that web services and SOAP are completely unrelated to Java. So the types you see here are in fact XML types, types defined by the XML standard, not types defined by Java. A second message is the getEmployee by ID response. So this appears to be the XML document that's going to be returned by the web service. That appears to include a first name of type string and a surname of type string. And I've omitted the rest of the contents of that message. And then in the XML block here, we're effectively defining the entire structure of the web service. Web services use the term port to denote a related group of operations. I'll tell you what, if you think of the port as just being your entire web service, you won't go far wrong for now. So here I'm defining a port or a web service called Employee Management Web Service, and it's going to have at the moment just one operation called getEmployee by ID, which accepts an input message, which we defined before, and will return an output message. And of course, as we go further with this, we'll be adding more operations to the port. As I say, this is heavily simplified, so if you haven't come across them before, we'll see a proper one later. And if you have come across them before, don't be too angry that I've simplified. I just wanted to give the general impression of what a Worstell looks like for now. They're not nice to read, but they're not meant to be human readable. The idea is that we can feed this Worstell into our programming language and then let our programming language work out the details of what it needs to send to the server. So the really great thing about web services is that the infrastructure required is really basic. If we're coding the server, all we need to be able to do in our target language is to be able to accept requests from HTTP and to be able to read and write XML documents. Now, our job in this chapter, and we're finally getting to some code at last, and I'm sorry about the long theory talk, but our job is to make our employee management service become a web service following the SOAP standards. Well, we could go off now and write an XML parser and decoder. We could write the Worstell by hand following the standards of SOAP. and we could somehow program maybe a Java servlet to accept those HTTP requests. All of that is simple enough work, but it would take ages and it would be really low level and, to be honest, really low value work. And this is where, at last, JavaEE comes in. The library for handling SOAP-based web services in Java is called JAX-WS. Another one of Java's great acronyms, it stands for the Java API for Web Services. Well, I should say this is for SOAP-based web services because since SOAP was invented, there is a second style of web service, and we'll be studying that in the next chapter. The JAX-WS library is purely for SOAP. Hey, it's actually a part of standard Java now, so you don't really need Glassfish to even make this work, but it is very tightly integrated with JavaEE and EJB and all of the topics we've covered on the course so far. And JAX-WS is really simple to use, or at least at first. We're just going to annotate our existing EJB class with the web service annotation. Once this annotation is added and the class is deployed, Glassfish will generate a full implementation of a web service for, in our example, employee management. It will handle the conversion of the incoming XML messages sent by the client into Java objects, and when we return data, like in the getAllEmployees method, the corresponding XML return message will be generated for free. Let me re-emphasize, we are never going to need to generate any XML. It's an amazing amount of magic that we're getting by and large for free. Now, don't get too carried away. When you have more advanced requirements, say you have very complicated Java objects to deal with, you might have to perform some manual intervention. But we're going to get a lot of mileage from this simple default behavior. Now notice that I've added this annotation to my existing EJB class. I think technically I should have created a separate class to represent the web service, and this new class could have called my existing untouched EJB. But since the annotation is really all I'm adding to the class, and nothing is going to need to change in the code, I'm usually quite comfortable with just adding it to an existing EJB. Now, the one parameter that I've added to this web service annotation is I've given it the name that I want the web service to be called by. This name here, I've called it Employee Management Web Service, will be used extensively by the client, as you'll see in the second half of this chapter. I didn't have to specify that property because by default, Glassfish would have given the web service the name Employee Management Implementation. Well, I'd rather my client saw Employee Management Web Service rather than the class name because that's a bit Java specific. So I think it's always worth overriding the default. Well, I think I've probably spoken for too long. Apologies for that. I think we've got enough to get some coding done. Let's go over to Eclipse. Okay, well, that was a long talk just to get us to the point where here's our enterprise Java bean, our service, our employee management implementation that we've been working on throughout this course. And at least to get us started, to make it a web service, it's a simple case of adding web service, notice the capital S on service there, as an annotation. And I'll import that. And if you check the import list, the import comes from javax.jws. Bit confusing that is the package in which the JAX-WS classes and annotations live. Now I could go right ahead and deploy this now, but as I mentioned on the caption, the one property I want to override is the name of the web service, just to give it a more friendly, outward-looking name. Remember, my clients don't know that they're calling a Java class. So I'm going to call this the Employee Management Web Service. I don't know if it matters, but I think on the caption I used the capital S for service. So I'll do that to be consistent. You can use any name you like in there actually, as long as you remember what it is. So that's our first step on the route to using SOAP-based web services. As always, I need to do a rebuild. Now in Glassfish, I just want to draw your attention before I do the deploy. I'm on my Applications tab as usual, and it's showing my Employee Management application here. Just make a note of the engines list here. At the moment, it's saying we're using EJB and the Java Persistence API, and we're using web as well. Well, take a look what happens when we do the redeploy. And again, we're using the web app as on the previous chapters. I'm going to hit OK there and take a look at the difference on this engines list here. You can see that it's clearly detected that there's at least one web service inside this project. So that's a very good sign. It must have done something with our web service. And now we're going to click on the application right there. And this is very important now. I'm going to scroll down and you can see one of the entries says view endpoint. I don't think it's immediately clear from this line because it doesn't mention web service, but the endpoint is effectively the generated code that JAX-WS has created for us that handles the incoming connections from the clients. If you like, the endpoint is our web service. And if we click on View Endpoint, we get a couple of really important links. Now, I must say, they do tend to fiddle around with this at Glassfish in the layout of this page. So your page may be a little different, but the key thing that we're looking for is the line Worstell. Now I'm going to follow this hyperlink, and you can see from my address bar here that there is a full URL appearing there. Now I'm running on Chrome. I don't know which browser you're using, but one of the weaknesses of Chrome is that it won't display XML documents. It just gives you a blank screen. But if you're running on Firefox or on Internet Explorer, you'll be seeing the Worstell right now in an XML document form. If, like me, you're running on Chrome, then you'll need to right-click and select View Page Source. Well, I did say in the introduction that Worstells are not very pleasant, and I think there's the proof. We're seeing just the top third of the Worstell here. If I scroll down, yeah, we've got something like 100 lines of XML just for our very simple service on this course. But I wonder if we can just have a look through and see if we can pick anything out. Well, you can see there's a definition of a message called get all employees. There's register employee. Oh, there's our exception. Oh, I've just lost it now. There it is on line 31 here. There's our system unavailable exception that we defined. That's been mapped into XML as well. And this is really quite wonderful. Without the help of JAX-WS, I'm really not joking that we would have had to sit down and craft this by hand. So JAX-WS really helping us here. Now, the key thing about a Worstell is that now all I have to do is to give this web address to my clients, and my client coders will now be able to access my web service regardless of the language in which they're working. Another thing I want to show you is that in Glassfish we have a really useful tool called the tester. Now, the job of the tester, this is not something that we would use in production at all, but it's something that we can just use just to make sure that our web service really is working. And we can have a little look under the hood at what's going on. Let's follow the link to the tester. Now, I really can't get across just how wonderful this is. This allows us to test our web service implementation. And what we're allowed to do is to use these buttons here to test the web service. So this is essentially a very quick and dirty client application that Glassfish has automatically generated for us. So I'd like to test if the Get All Employees web service is working. I'm going to click the button there. Oh dear, this is a deep disappointment. And it's thrown an exception with message null. Thank you, that's not very helpful. It's telling me to refer to the server log for more details, which we could do, but in fact there is the exception that's being thrown appearing on this page here. I'm sure I must have said this at some point earlier in the course, and I've definitely said it on previous courses that I've recorded, but please don't panic when you see these massive, and it really is an absolutely gigantic call chain. Because the problem with working on these heavy server-side applications is that we've got a lot of layers, most of which are nothing to do with us whatsoever. We're seeing here every single layer of networking and remoting and conversion and all sorts of things that we stand no chance of understanding. I'll pick a random line. What's Grizzly? What's the protocol chain context? I don't know. I don't care either. The art of working with exceptions, and it is a bit of an art, it's something that just comes over time and practice and experience, is to kind of scroll down the exception and just search out something that you recognize that we're in control of. And I can see here some SQL, an SQL statement. Now, we designed those SQL statements in JPA earlier in the course. I can see a select statement going on here. Well, that looks pretty good. I mean, the fact that there has been some SQL, it's clearly trying to select all of the employees, and the SQL has failed. So there's our first clue. And if I go a little further down, again, a lot of junk and a lot of noise. And, well, I've got all the way to the bottom and I still can't see anything. Hey, I'll go with that. A communications error has been detected. Well, I'm still not sure that's a particularly clear error, but I now realise it's because I forgot to start up my database. So a really trivial error, which has a very basic fix. All I need to do is go into my Derby installation and the bin directory and type start network server. I hope you've been doing that throughout this course at the start of every session. I could edit that out of the course, but I wanted to leave that in just to remind you that everybody has these types of problems, and it's very easy to see these huge call chains and get really depressed and think that something unpleasant has gone wrong. It was very basic. I'm going to go back a page now. The DB's up and running, so I'll try Get All Employees again. And I just adore this tester. It's telling us here the parameters that we sent to the web service. And it's telling us that the method has returned a list of Java objects. And this, although it does look ugly, it is saying that we do have employee objects being returned from the web service. It's trying to call the toString method on each of those employee objects, but it's not getting anything meaningful back. I'll talk a bit later about why that's happening, but it's really not a problem. And we can see it isn't if we just scroll down a little further. Now, this is wonderful. This is showing you the SOAP message that needed to be sent to the web service to make this process happen. Now, I mentioned this in the introduction that SOAP messages have really quite a complicated structure. They have to be very precise and you have to add things like XML namespaces in there. but I can tell you that this is the form of the SOAP message that we would need to write in order to invoke the getAllEmployees method. And wonderfully, a little further down, it's showing us the response from that web service. And it's showing us that we did indeed get an XML document back with the data that you recognize and have come to love from this course. All of our employees appearing in that XML form. And it's automatically generated all of the extra stuff that the SOAP standard demands. So we got all of that for free just by adding an annotation. Well, this tool is just to sanity check your web service, just to make sure that it's really operating properly. But you're not going to be giving this to clients, of course. The thing you're going to give the client is the Worstell. And again, I'll follow the link to the Worstell from there and view page source. I'm going to give my clients this XML document, the Worstell, which describes the web service and allows them to call it. In this chapter, we've made a start on understanding web services. I had to begin by explaining the general concepts behind web services because I'm sure many of you won't have come across them before. They're not specifically a Java topic. They came from outside of Java, and in fact Microsoft were the original pushers behind web services in the late 90s. So we've had a look at what a web service is. We can write a web service or call a web service from pretty much any language. There are two big jargon terms in web services. SOAP is the general protocol that we're using in web services. And the main part of SOAP is the structure of the messages that we can send to a web service and return from a web service. Worstells are really important. They're an XML document that describes the contents of a web service. It's the contract definition, if you like. And the great thing about a Worstell is that's all a client needs to be able to fully understand the web service and to know what messages to send and what messages it will get back in return. The trouble with Worstells is they're pretty complicated, but we saw that in the Java library of JAX-WS, a lot of the hard work is done automatically. We used an annotation on our existing EJB, and that became effortlessly a web service with a corresponding Worstell. I must warn you that when you start to get more complicated requirements with web services, you might have to do more manual work. But that's some way into the future. Often, JAX-WS is able to handle most requirements. We've only told half of the story in this chapter. We've coded a web service and we've published it and it's live. But the other half of the story is, how do you call a web service? Well, we'll be covering that in the next chapter when we'll see how to code a SOAP client. So, I'll see you in chapter 17.